Now that we have looked at a confidence interval and a hypothesis test for the difference of two proportions, let's do the same for the difference of two means. So we want to look at two samples of data, and they're very small samples, but we're looking at the lifespan of batteries in minutes for brand name batteries and generic batteries. And before we make an interval or do a hypothesis test, let's look at the data and just make a prediction. So just for fun, I went ahead and found the summary statistics for each, and I did some parallel box plots. And that kind of is very telling. Like before I ever do an interval or a test, it seems pretty clear to me that the generic batteries are doing a heck of a lot better than the brand name batteries. Because when I did these box plots down here, even if I didn't look at the summary statistics, this is 50% of my data right here. And that's greater than the highest 75%. I mean, look at this value here. I mean, clearly, just visually, generic is doing better. Okay, so we know that just going in. Now, do I ever have to do that before I do a test? No, but I'm just showing you that there's more than one way to look at this. But let's look at how we would do an interval or a test. So again, we have to check the conditions: independence, randomization, 10%, and nearly normal. And we've done all of these before. And keep in mind that we're looking at groups and not just one set of data, but two sets. So we have to check them for both. So now I have to check my conditions, and notice it's telling me that we're taking generic minus name brand. So that's given to me in the question. And also notice, again, I would be looking at that flow chart to say, okay, I have two sets of data that are means, so means, two sets, and then are they independent or not? So this one we're looking at two random samples of different batteries. Those should be independent of one another. I didn't take them from the same company because one of them is generic and one of them is brand name. So they're just random selections and therefore they're independent. That's important going in because you have to choose the right test. Now let's check conditions. Independence, again, the longevity of brand name batteries doesn't influence longevity of generic batteries, so I'm saying the groups are independent of one another. If they weren't, then I would have to do a different test, which we haven't learned yet. Randomization, it's not stated, but we're going to assume the batteries are chosen randomly. 10%, 6 batteries is certainly less than 10% of all brand name and of all generic batteries. And nearly normal, notice I've got the battery length here, the name brand here and the generic here. And these are the values that I'm going to use. So to check nearly normal, I would go to graph, and then QQ plot. And I'll look at name brand and generic. And I'm going to do 2 columns per page so that I can see them side by side. And notice that I've got a pattern here. And I have a kind of a pattern here. And so if I were doing this for real, I would say, nope, I'm not going to continue because I'm not comfortable with this. Remember, the other way to look at it is to go to graph and then go to histogram, and again choose name brand and generic, and I'm going to again do 2 columns per page just so I don't have to flip back and forth between them. And I'm not liking that either one of these look normal. So in real life we would say, nope, this nearly normal condition is not met and we're not going to continue. But for the sake of practice, we're going to continue anyway. But again, say this were a test question, I would say this condition is not met and therefore we're not going to continue. So again, here we're finding a 95% interval. We already have these values here in our data set. So I'm going to go to stat, and this is t-stats because remember this was means, 2 different means, and I have 2 samples, and this is with data because the data is in my spreadsheet. I'm going to choose, because it tells me to, generic and minus name brand. and then I'm choosing a confidence level of 95% and compute. And these are the values that I come up with. So what do those values mean? It means that I'm 95% confident that generic is outlasting name brand batteries by between 2.1 minutes and 35.1 minutes on average. Again, when you're dealing with means, you should be labeling. It's not just a percent anymore. Now we're dealing with an actual, label that we should be using. Here's a question for you to try. And this question asks about the differences between endoscopic surgery or open incision surgery for carpal tunnel syndrome. And it gives you some average or mean pinch strengths. So hopefully very clearly this is going to be a means question because they're giving you average pinch strengths. And they're giving you one for endoscopic surgery patients and one for open incision surgery patients, so hopefully it's clear that there's two different results. What's not clear maybe is this independent or not? So keep in mind that we're randomly assigning people to the groups and then looking at their mean pinch strength after surgery. And so this would be considered independent because there's nothing that would tie the results together. Nothing that ties them together. It's not the same person. It's not the same anything. So this should be a 2 sample T interval. So go ahead and press pause, do all your calculations in StatCrunch, then press play to see how you did. So again, I went ahead and checked conditions just because it's a good idea to always do that. Independent pinch strengths of the groups are independent of one another. All patients are randomly selected. 12 is less than 10% of either endoscopic or open incision patients, and nearly normal. Honestly, there's no way for us to tell. So the fact that there's only 12 in each group doesn't make me feel good. We don't know that they're from a normal model. So again, I would be cautious to move forward in the real world, but for the sake of practice, we'll continue anyway. Then we do our all of our calculations in StatCrunch, and notice all I did was choose population 1, population 2, which meant I put the endoscopic patients first, so I did 9.1 first, and then I did the open incision, which was 7.6 second. And how do I know for sure that I did that? Because the difference was 1.5, and obviously the difference is positive. And then we're constructing a 95% interval, so I chose 95%, and those were my values. So what does that mean? Again, I threw in there assuming the data sets are nearly normal because I wasn't given that information, so I'm just saying in my conclusion I'm not real sure about this. But it appears that the mean pinch strength of patients of endoscopic surgery exceeds the mean pinch strength of open incision patients by between 0.714 kilograms to 2.286 kilograms. Now let's take a look at hypothesis testing with two means. So again, I'm going to use the null hypothesis. Is always going to look like this. Now this is a little bit different than the last one, because on our last video, when we dealt with proportions, we had P1 minus P2 equals 0. And now I'm dealing with means, so I have mu1 minus mu2 equals 0. And again, when I actually do this question, I'm going to use something besides 1 and 2 so that I know which group I'm actually putting first. Then the second one, the alternative, is always based on the context. But again, we're sticking with 0 as the difference because we're assuming that there's not going to be a difference in whatever the two averages are. Let's look back at our carpal tunnel question that we just did a confidence interval for, and we already checked the conditions, so we're not going to do that again, but we're going to do a 2-sample t-test, which is also called a difference of means test because we're finding the difference of two averages. When we constructed our confidence interval, we found an interval of 0.855 and 2.145 at 95% confidence. So then we have to find the alpha level, and of course our alpha level should be based on our hypotheses. So again, let's look at our hypotheses. My null hypothesis should be real easy because I'm expecting that endoscopic minus open should be a difference of 0. There's no difference in mean pinch strength. My alternative hypothesis, if I read through the entire question again, it doesn't say that we're expecting endoscopic to be better or we're expecting open incision to be better. It's saying, let's see how effective these are. Is there a difference, essentially, is what we're trying to find. Is there a difference between the healing time of these two different types of surgery? So notice I've chosen the not equal to. So not equal to means it's a two-tailed test, and so to find my alpha, I just take 100 minus the confidence interval, or my confidence interval is equal to just 100 minus alpha. So either way, I'm going to get 5%. So now let's look at how to do this hypothesis test. Again, we're going to do our calculations to go to stat, t-stats because it's two averages, to sample, and this time I have a summary because I don't have data in my columns, I just have summary. And my sample mean is 9.1 because it says to do endoscopic first. So I'm doing 9.1 pinch strength, standard deviation of 1.2, sample size of 12. The second one should be open incision. An open incision had a mean of 7.6, had a standard deviation of 0.4 kilograms, and again 12 because it says 12 in each group. That's how I knew my sample size was 12. So again, never click that pool variances. We'll leave it just like this. We're going to go down to hypothesis testing. And remember, our alternative hypothesis was that there was a difference. So I'm going to leave it just like this and click compute. And I get my my p-value of 0.0012, which is very small. So my conclusion says, since 0.0012 is less than the alpha level of 5%, we will reject the null hypothesis. There's evidence to support that the average post-surgical grip strength differs between endoscopic and open incision patients. Again, that's just the alternative hypothesis in words. I'm 95% confident that the mean pinch strength of patients of endoscopic surgery exceeds the mean pinch strength of open incision patients by 0.714 kilograms to 2.286 kilograms. This supports our conclusion since 0 is not in the interval. Again, those two values were found when I did the confidence interval previously of 95% and found those two values. Last one of these to try. We have already checked conditions together, so what I'd like you to do is come up with the correct hypotheses, do your work in StatCrunch, and write an appropriate conclusion. And if you can, go back and include the correct confidence interval that we did before. Make sure you're using the correct alpha. So press pause, try it all, and then press play to see how you did. So this question says, is there a significant difference between battery life in minutes of brand name versus generic batteries? And they ask us to take generic minus brand name given in the question. So I've already checked my conditions, so I didn't have to do it again. My hypotheses were that there's no difference, and then that there is a difference, but I don't know what that difference is going to be. So is there a significant difference being not equal to? My conditions have already been met, so I'm going to look at what alpha level I should use. Previously, I gave you a 95% interval. So again, I just took alpha equals 100 minus 95, or 95 equals 100 minus alpha. And again, that's because this is a two-tailed test. If it was a one-tailed test, it would be 100 minus 2 alpha. But again, remember our previous interval was 2.1 to 31.5, so I'm going to use that when I come over here to write my conclusion. In StatCrunch, I simply chose the correct columns of brand name and generic, and I made sure to put generic first because they told me to. And I used my correct not equal to and found my p-value of 0.0313. And again, knowing that 0 was not in this interval, because 0 would be over here somewhere, I would have already known that I should reject the null, but I'm going to go ahead and do the test anyway, of course. So since 0.0313 is less than the alpha of 5%, we reject the null hypothesis. There's evidence that this is true, and that means there's evidence that the average battery life of a brand name battery differs from the average battery life of a generic battery. And I'm 95% confident that on average, generic batteries will outlast brand name batteries by 2.1 minutes to 35.1 minutes. This supports our conclusion since 0 is not in the interval.